Good morning, students. In our last class, we started learning about hydrogen, isotope of hydrogen, what is the position of hydrogen in the periodic table, what is the difference between ortho and para hydrogen, and how to convert ortho hydrogen to para and para hydrogen to ortho, as well as what are the method to prepare the hydrogen, that is the laboratory method, industrial method, as well as the important method called to be the electrolysis method, where hydrogen is obtained in very pure state, that is greater than 99.9% of hydrogen is obtained by doing the electrolysis process. All those things we have learned. Now in this video we are going to learn the physical properties of hydrogen, chemical properties and uses, what is deuterium, what are tritium, all those things we are going to learn in today's video. Physical properties of hydrogen. The first one is it's colorless, odorless, tasteless, lightest and highly inflammable gas. No color, no odor and no taste, as well as lightest and highly inflammable gas. So let's watch this video. It proves that hydrogen easily catches fire, that is inflammability will be shown by this. Here in this tube hydrogen gas is filled, so it easily catches fire. Second property is it's a non-polar diatomic molecule. Non-polar means it will not carry any charge. So because it's a hydrogen, two hydrogen together, it's a diatomic H2, H bond H. So the electronegativity difference between both the hydrogen are 0. So hence it is a non-polar molecule, does not carry any charge. The next, it can be liquefied under low temperature and high pressure. When the temperature is maintained below 33 Kelvin, that means nearly minus 250 plus degrees Celsius. Okay. So it can be liquefied only at that extreme low temperature and at a high pressure. Look at here, the hydrogen gas is converted into the liquid. Next one, it's a very good reducing agent. In the metal oxide can be reduced in the presence of hydrogen. Chemical properties of hydrogen. The first property is reaction with oxygen. So when hydrogen reacts with oxygen, enormous amount of energy is released. So the reaction is highly explosive. So that energy, it releases much energy, hence this hydrogen can be used as a fuel cell to generate electricity. So the first reaction between hydrogen and oxygen gives the water molecule, that is H2O. Reaction with the halogen. Hydrogen reacts with the halogen. Halogen means fluorine, chlorine, bromine and iodine. So this hydrogen, when it reacts with fluorine, give you the respective product called to be hydrogen fluoride, but this reaction can carried out even at the dark. So even at the dark, the reaction, that means the reaction will take place very faster, and the reaction, the product will be formed like a explosive violence. So the HF is formed. So likewise, when hydrogen reacts with chlorine, here this reaction will not carried out in the dark, but at the room temperature under the light. So only at light the reaction carried out, and you get the product called to be hydrogen chloride. So likewise, hydrogen reacts with the bromine to give you, only after heating the mixture you get the product called to be hydrogen bromide. But the hydrogen and iodine, it react only in the photochemical reaction. Photochemical means in the presence of light energy. This mixture will absorb the light energy and get converted into hydrogen iodide. So this is the general equation. The hydrogen H2 plus, the halogen can be represented by X, and halogen always in the diatomic state, so it is represented to be X2. So H2 plus X2 give you 2HX. Reaction with the metals. Hydrogen reacts with the metal to form a respective metal hydride. So in this molecule, the hydrogen oxidation state is said to be -1. Normally in the other compounds like hydrogen halide. Hydrogen carry the oxidation number of +1 and halogen carry -1. But here it is just reverse. The metal carry plus oxidation state and the hydrogen carry -1 oxidation state. So here when lithium treated with hydrogen, you are getting lithium hydride. Likewise, when sodium treated with hydrogen, the product obtained is called to be sodium hydride. So generally metal with hydrogen give you metal hydride. The hydride which we got in the previous reaction, that is when hydrogen reacts with the lithium, you get lithium hydride. When sodium reacts with hydrogen, you are getting sodium hydride. These both hydrides are very good reducing agent and can be used in organic chemistry for synthesizing various organic compounds. More than that, this hydride is used to prepare the other important reducing agent which is called to be lithium aluminum hydride and sodium borohydride. When lithium hydride treated with aluminum chloride, you are getting the product called to be lithium aluminum hydride plus the byproduct is lithium chloride. The same manner, when sodium hydride is treated with trimethyl borate, you are getting the product called to be sodium borohydride plus sodium methoxide is obtained. The same way here, the hydrogen compound, lithium hydride is the compound of hydrogen and lithium aluminum hydride can also be a compound of hydrogen. Both can be very good reducing agent. Likewise, this hydrogen itself acts as a good reducing agent. When this hydrogen is added with a finely powdered nickel, that this nickel is acting as a catalyst. It allows the unsaturated compound into the saturated compound. The unsaturated compound means compound with either double or triple bond. Here I have taken a triple bond compound which is general formula is alkyne, general. But this is 2 carbon atoms, so its specific name is called to be ethine. When this ethine is treated with the hydrogen in the presence of a catalyst nickel, you will get the product called to be ethene, E-T-H-E-N-E, ethene. The general name is called to be alkene. When this ethene is further treated with nickel and hydrogen, you are again getting 2 more hydrogens are getting added. You are getting the product called to be ethane. So this is ethine, Y-N-E, this is ethene, E-N-E, this is called to be ethane, A-N-E, single bond. So unsaturated compound is converted into a saturated compound here. This hydrogen is acting as a reducing agent. Uses of hydrogen. Over 90% of hydrogen produced in the industry is used for synthetic application. That means it's used to synthesize a new compound. So one of the example under the synthesis is Haber's process. The Haber's process is used to synthesize ammonia. So the ammonia formula NH3, it is obtained by treating nitrogen and hydrogen. 1% nitrogen and 3% hydrogen. That is 1:3 proportion. Nitrogen and hydrogen heated at the temperature of 380 to 450 degrees Celsius. And the pressure maintained is 200 atmospheric pressure. And there is a catalyst used is called iron as a catalyst. When N2 plus H2 reacts, you are getting the product called to be ammonia. And this ammonia is used for the manufacture of nitric acid, fertilizers and explosives. You know nitric acid formula HNO3. So the nitrogen is there. From ammonia we can obtain this nitric acid. Likewise, it is used to prepare the fertilizers. Fertilizer I have written one that is nitrogen compounds, nitrates. So one example is ammonium nitrate. This is one fertilizer. This ammonium nitrate is obtained by treating ammonia with nitric acid. When these two combine, you are getting NH4, NO3, ammonium nitrate, and a very good fertilizers. The next one is explosive. So for the explosive, there are 3 explosive I have written here: picric acid, TNT and RDX. All that nitrogen is present, and these explosives are prepared by using this ammonia. Then important one, it can also be used to manufacture the industrial solvent called to be the methanol. So this methanol is obtained from water gas. You know the formula water gas, that's nothing but carbon monoxide and hydrogen. The other name of this water gas is called a syngas. Why we call it as a syngas? Because it is used to synthesize an organic solvent. So by combining carbon monoxide and hydrogen in the presence of copper as a catalyst, you are getting the product called to be the methanol, which can be a very good solvent, industrial solvent. Another important use is in metallurgy, hydrogen can be used to reduce many metal oxides to metal at high temperature. So the metal oxide here, copper oxide, another one is tungsten oxide. When these oxides are treated with hydrogen, this hydrogen will take away the oxygen and give you the copper and tungsten. The byproduct will be the water molecule. So the metallurgy is nothing but the process in which the extraction as well as the purification of metal from the ore is called to be the metallurgy. So in that process we can use this hydrogen, and that hydrogen can act as a reducing agent. The other one, unsaturated fatty oils can be converted. Unsaturated means compound with a double bond or triple bond. So unsaturated fatty oils can be converted into saturated fat. Saturated means single bonded compound called as vanaspati. This by the reduction reaction with platinum and hydrogen or with nickel and hydrogen. Here there is a vegetable oil which is having double bond, alkene, unsaturated, and treated with hydrogen. When two hydrogen are going and adding here, the double bond, one bond will get break, another in that place the hydrogen will go on join. You get the product called to be alkane, that is saturated compound. So another important use of hydrogen is atomic hydrogen and oxyhydrogen torches are used for cutting and welding. Look at here, this is oxyhydrogen torch which is used for cutting and welding purpose. Another one, the liquid hydrogen is used as a rocket fuel. So a lot of fuels are used instead the liquid hydrogen, which will be cheap and best. Another one, used in fuel cell for generating electrical energy. So already we have studied this hydrogen can be used in a fuel cell and can produce the rechargeable metal hydride battery by using this hydrogen.
Norsk Hydro were using hydroelectricity to make hydrogen. It's actually not a very hard thing to do. If you pass electricity through water, which is H2O, you can break it apart into hydrogen and oxygen. So, as you can see, we're collecting hydrogen here in this test tube, which is basically all that Norsk Hydro were doing, just on a vastly larger scale. And then they'd take the hydrogen and use it to make fertilizer.
But a few years before the war, scientists made an extraordinary discovery. A new kind of hydrogen. One where the nucleus contained an extra neutron, making it heavier. Scientists called it deuterium. And just like normal hydrogen, deuterium combined with oxygen to make a new kind of water. Heavy water.
We call it heavy water for a very simple reason. I've got some heavy water here that we've frozen into heavy ice, and if I just drop it in this glass of ordinary water, you can see it sink straight to the bottom. Now, heavy water is actually present in ordinary water. It's about 0.01%. Or in other words, in this 5 liters of ordinary water, there's about that much heavy water. And one of the side effects of the process of breaking up water into oxygen and hydrogen is the heavy water is very slightly harder to break up than the light water. And so you end up with the water that's left behind having a slightly higher concentration of heavy water. And if you do this again and again and again and again and again and again and again, you can eventually end up with this, which is essentially pure heavy water. This is from Norsk Hydro. It's 99.76% pure heavy water.
You can do the electrolysis process. When you electrolyze it, you will get the deuterium and oxygen. Chemical properties of deuterium. As you all know, that hydrogen reacts with oxygen, give you water molecule. Likewise, deuterium reacts with oxygen to give you heavy water. Formula for heavy water is D2O. And then This deuterium can also react with halogen. So X is nothing but halogen. Halogen can be fluorine, chlorine, bromine and iodine. So when deuterium reacts with halogen, you get the product called to be deuterium halide. So these are the two chemical properties. Another important reaction of deuterium is exchange reaction. This deuterium can exchange the hydrogen or can replace the hydrogen partially or completely, depend upon the situation. Either for exchange reaction I could use the deuterium or deuterium oxide, that is heavy water. Here specifically deuterium, that when methane react with deuterium, all the hydrogen atom, all the 4 hydrogen atom are replaced by deuterium. So you are getting the product called to be deuterated methane, carbon or methane, CD4 plus hydrogen. Likewise NH3 when treated, all the hydrogen atom will be replaced by, so this is called to be heavy ammonia. This is heavy methane, this is heavy ammonia or deuterated ammonia plus hydrogen is obtained. And there are some more reactions. Water plus D2, all the hydrogen will be replaced and you will get D2O. Look at the condition and temperature 200 degrees Celsius and platinum. So you are getting heavy water, ordinary water converted into heavy water. An ammonia reaction just now we saw where they haven't given the mentioned the condition, but here in the presence of nickel, deutero ammonia. Another one with methane, already we have seen deuteromethane, condition 200 degrees Celsius to platinum. Then next one, benzene, all the 6 hydrogen atom will be replaced by deuterium, so the name is deuterobenzene. So these are the examples of exchange reaction of deuterium. Another isotope of hydrogen is tritium. First hydrogen, deuterium and then tritium. Tritium, you know the formula 1T3. And this tritium is present very trace amounts, hence it can be prepared artificially in the laboratory via radioactive disintegration. For that, lithium is bombarded by slow moving neutron 0n1 in the nuclear fission reactor. When it hit the lithium, it breaks into 2 almost equal size nucleus or molecule, that is one is helium, another one is tritium. So 3Li6 is lithium and this is called as neutron. You can look at here. So the lithium is the heavy particle. It was attacked by the neutron, slow moving neutron. It breaks somewhat into 2 equal half, that is helium and tritium. Next, properties of tritium. This tritium can disintegrate into helium and it emit beta particle. So the beta particle, its formula or beta emitter, it formula is -1 E0, that is electron. Look at this picture, this is tritium. Go to the excited state and there is electron and it is emitting that electron. That emitted electron is called to be the beta ray, and this is the helium, He3. So see that right hand side -2 -1, it is 1. Okay, so tritium get converted into helium with the emission of beta particle. The next one with the half-life period, that is tritium have a half-life period of 12.3 years. So what is half-life period? The time required to disintegrate 1/2 of its original substance. That is, if you are taking 100 gram, how much time required to disintegrate 100 into 50? That is, A0 is the initial concentration. The time required to convert A0 into A0 divided by 2. So that is half T. The next 2T, that is nothing but A0 by 4. 3T is A0 by 8. It is 16 and 32. So that's called to be half-life period. So the half-life period of tritium is 12.3 years.